Hello everyone. Sorry for the late start. I was having a epic battle with an avocado, but that has passed, and I will be starting my stream now. So I'm sorry if some of you guys jumped in and then had to and then left because you thought that the stream wasn't happening, but I will be going on with the stream anyway. So today you'll see on the side I have the AI that we've been running in the past few streams, and that is the, hold on, let me get this this video away from the picture there. Okay, so you'll see that we have the AI running from what we've had in the past few streams, and the score is about the same that it was at the end of the last one. This is because I haven't been running it between the streams. I've been saving it so that you guys can see all of the progress that it makes, and it has been making some progress across these streams. You will see that the string of dots, the string of blue dots, makes some intelligent decisions by changing directions every once in a while. And also it sets itself up to be able to catch the red dot by making an L shape and moving upwards slightly and to the side slightly. These are good traits to see, and they are not the most intelligent traits, but they are on the right track. And so what we'll find is a combination of all these different traits in the correct order will find the best program. And you can see that it just caught the red dot there. So that's the general update on the AI here. And so today you might have heard on social media, but I will go ahead and tell you what I'm going to be talking about. Today I'll be talking about, well, I said airplanes and paper cranes. So today I'm talking about the Bernoulli effect. And to do so, I will pull up the paint window here. Okay, so you can see my cursor. So the Bernoulli effect is kind of, to say the Bernoulli effect, a lot of people don't really know it as that. But basically, this is the reason that planes can fly. So the reason that planes fly, it's not magic. It's actually some relatively simple science, but it may not be what you were thinking about right off the bat. So first off, let's draw. My computer's making a lot of noise. First off, let's draw a wing. So you may think that a good wing, well, you probably don't think this, but a good, let's just draw an oval. So with this, you can see, so an oval is fairly symmetrical. This picture isn't the best drawing, but with an oval, the air will flow straight towards it, up and over, and then some air will flow straight towards it and then around the back. So we have all this air, and it keeps flowing, and you'll see that eventually, because there can't be this void space here. There can't be this void space here, so the air has to meet back in the back of the wing here, and that's the wing, just so it doesn't get lost. Hold on, I'm gonna stop the stream for a second to see if I can get this sound to stop on my computer. Okay, I don't know if I'm going to be able to get rid of that sound, but if you guys are watching, give me some feedback on how bad that is, because it sounds pretty bad from my side. But so as I was saying, the Bernoulli effect So with the air around an oval or a symmetrical shaped wing, the air will flow back and will meet in the back of the wing. So when you think about the speed that these streams of air are going, you would think, because this is symmetrical, the speed that the air on the bottom is going the same speed as the air on the top. So because of this, nothing happens, and so this is a bad design for a wing. So let's go to what plane wings actually look like. So if we have a flat bottom and then a teardrop. Alright, so here's our wing. And this may seem a little unintuitive, but with the Bernoulli effect it'll make sense. So what happens is the air comes and it flows over the wing. Doesn't have to go that close, but that's just how I drew it. And then the air also goes under the wing, and you'll see that the air flowing under the wing here, these streams of air, are relatively straight streams of air, and this stream going over the wing, this wing here, I'll color it in a little bit more, has to curve up before it can get around to the side. So if you think about that a little bit, if you have a shape like this, then the distance over the top is longer than the distance over the bottom. So what you'll find is that in order to compensate for having to go this further distance, the air actually goes faster over the top of the wing than over the bottom of the wing, which, because nature doesn't want to have any voids or any vacuums here, the air will molecules spread out somewhat, which if you think of in a container, when the air molecules are spread out, then what do you get? Well, you get a lower pressure in that container than normal atmospheric pressure, and if they're pushed together more, then you get a higher pressure. So what happens is you get a low pressure zone over the wing and a relatively high pressure zone relative to the top of the wing under the wing. And when you have a low pressure zone above and a high pressure zone below, then the object will want to move upwards to will want to move towards the low pressure zone, because that's how things things in physics work. So you want to move towards the lower energy. It's like how if something is hot, it will dissipate its heat towards things that are more cold. So the lift isn't necessarily from the air pushing up. It's actually from the air above it pulling up by creating this low pressure zone and getting the wing to want to lift, which is what the term is. Which in talking about airplanes, we talk about lift. So the whole idea of the Bernoulli effect is that the lift is created by the air having to go faster over the wing. Okay, so that may have been a short description, and if you have any questions, you can ask them at the end. But with that, I'm going to play a short ad, and then I'm going to move into the section that I have been doing in the past few streams with the random words in the middle, and then I will move on to the section about paper cranes. So I will be playing a short ad, and I'll be right back. Had to get out my calculator here for the random number generator. Okay, I believe we're back. So like I've been doing in the past few streams, in the past solo streams, I have my calculator out and I'm going to find 3 random numbers which will associate to words I have on this piece of paper here, and I will try to describe the random topic that is generated. So the first random number is 25, so that noun is a flamingo. The second random number is 1, so the verb is run. And the third random number is 21, and so that means that the adverb is haphazardly. So if a flamingo, so we'll get pink here, if we have a flamingo, then it's going to be relatively pink. And actually flamingos are born white, but they eat a lot of shrimp, so we'll assume that this is a flamingo that is fairly good at fishing. So he's very pink. And so I'm going to just color in some of the details here. Okay, so it was a flamingo running haphazardly, and it may be that flamingos don't have yellow beaks or legs, but actually I think they are pink. So we'll get a different shade of pink here. Alright, hold on. Okay, so we're going to get a different shade of pink here. And that actually does look a little more like a flamingo beak, so that's good. So flamingos, well, okay, so one thing that would cause a flamingo to run haphazardly is the fact that they have backwards knees. So when they have their feet out here in the water, I'm going to put some water in here, then you would find that the flamingo wouldn't necessarily have the right angle to run here, because you can see the knees here are backwards. So the flamingo needs an eye just to make it not scary. But so yeah, with these backwards knees, the flamingo would not be able to run very fast, and it would be that is somewhat why flamingos tend to fly to wherever they want to go, or at least hop. But yeah, if a flamingo started to run, the angle of these legs here wouldn't necessarily be apt for the motion of running. It may be better for a springing motion where the bird sort of bounces along, but you'll find that with the water here, there's also a lot of drag in the water, so we get some trails off here. That was supposed to be gray, but we'll just act like that was on purpose. So the flamingo will be dragging its feet in the water, which already causes a normal running animal to have problems moving fast. But because of these backwards knees, the motion it needs to pick up and then put back down is not the most efficient motion for running, especially for running long distances, considering the size of the muscles on their legs, which are almost non-existent. So, I don't think that there is any other way a flamingo could run, and so I would assume that any running by a flamingo would be relatively haphazard. But if the shrimp are on sale or at the buffet is giving out shrimp cocktail, then the flamingo may feel it needs to be more pink, so it will run however it can. This is supposed to be pink. It will run however it can to get the shrimp cocktail. So the flamingo here will run to the cocktail, and the cocktail will probably be orange, just because that's how it usually goes. Maybe a little red, reddish orange. Alright, but I think that is a finished product. So to summarize here, the angle of the backward knees is not the most efficient angle for running in general, but because flamingos are normally in the water, the flamingo would be dragging its feet, and it would not go very fast. And also, it would be more efficient if the flamingo were hopping along using its wings to generate some lift, but you'll find that these wings do not use the Bernoulli effect. They are specifically with the thrust downwards, so it is physically the air below the wings pushing the bird up. But because the bird is so light and the wings are so large, the drag of the wings is able to create enough lift for the bird to fly. So, with that being said, I'm going to play another short ad, but I will be right back with my segment on paper cranes, which are not flamingos. If you were thinking that, I'm not sure why you would be, but yes, so I'll be right back. And my computer continues to screech, but we will live with it. Okay, I believe we're back. I've angled the camera downwards so you can see the paper I'm working with a little better, but I will be holding the paper up with each step. So like I said, I'm going to be talking about paper cranes, but not only will I be talking about them, I will be showing you how to make a paper crane. So I'll give you 30 seconds or so to get a piece of paper if you wish. And in the meantime, I will be playing assorted banjo picking. That was terrible. Okay. I will assume that you have a piece of paper, or if you are watching this later on YouTube, you can simply stop the video here and go get a piece of paper and take as long as you want, because that's how YouTube works. So, if you're starting with a rectangular piece of paper like I am, then we will need to form a square. So, what I'm going to do is I will be folding the corner down until the top of the paper, the top, meets the side of the paper, and make this trapezoid here. So I'm just going to pinch it so that it's visible. So you'll see the paper folded down to the edge, and then I just take my thumb and run it along that crease just to make sure that the crease is defined and flat, because you don't want a lot of slack on the paper. It will cause problems later. So now you'll see you have this this triangular region and then this section on the bottom. If you're going for something more sophisticated, you can simply cut the section on the bottom off, but I'm too lazy to do that. So what I'm going to do is you'll be able to see the line that the paper has created with the fold. So I'm going to fold it over that line. So I will fold it and I will show you what it looks like. And like I said, if I'm going too fast or anything, this will be up on YouTube later, and I will cut this section so that it is easier for you to simply get straight to this section. So let me get back to, so I don't get ahead of you guys. Alright, so now it's folded over, and I will unfold the first fold that I did and fold this down. So now you can see we have a square section of paper. There's this folded section, but like I said, if you're not trying to be too sophisticated, this section won't matter. It won't really cause too many problems. So now what we're going to do is we're going to do the same fold we did, but include the corner of this rectangular section. So I will fold that down, and now we have an isosceles triangle. That is, the sides are the sides of a square, and the diagonal is the diagonal of the square. The hypotenuse is the diagonal of the square. And this is also a right triangle. As I said, hypotenuse, so it is isosceles and right, but not equilateral. So the next step is to take this triangle and fold it in half. So I will fold it in half. And you should be getting a smaller isosceles right triangle that is similar, as in the geometric similar, and it is also abstractly similar to the first triangle that you had. And you'll see it is like one of those fancy napkins that they fold at the at fancy restaurants, except there are no silverware, there's no cutlery, so you are safe with this piece of paper. So from here it gets a little more complex, and so I'll try to explain what I'm going to do first, and then I will do what I'm going to do, and then I will show you and attempt to work backwards a little bit to show you. So what I'm going to do is I'm going to take the corner of one of these sides and see how it opens up. So I want to take the open side, and you can stick your hand in there a little bit, and you're just gonna put your thumb on the crease in the back and push down until the tip of that side meets the corner, and it should form a square with a diagonal across it. So I'm just going to push down the sides here and form creases along the corner, the edges of the square, and so now it is actually a square that you can open up, and that will become important later. But like I did before, I'm going to take my thumbnail and run it across the creases. So now I have a flattened square section of the paper. And I'm just going to take the other side, so now it kind of looks like a shark fin or something. I'm just going to take the other side and do the exact same thing. So I will open it up with my hand, push the tip of the triangle down to the bottom of the page, and then accentuate the creases with my thumbnail. So now we have two rectangles. Yes, they are rectangles, but these are specifically squares, and they are also rhombuses, and they have this central diagonal. And then they also open from one side, one corner, which is important for the next step. So this step is also somewhat abstract, so I will attempt to explain. So we're going to open, so I want you to pick a spot that is about 3/4 of the way up the diagonal with the opening side on the bottom, and simply push that part of the crease inside out. So then you're going to lift this corner up, and that 3/4 might be a little bit too low, so I would say maybe 7/8 up the page, or somewhere in between. So you'll just have to work it a little bit, and you'll see that the inside has this flat area, and you'll want to work that flat area until you can open up. And actually, I keep moving it down from where I had said, so it might actually be about that 3/4 or even lower. Until you want to work it until you can pull the corners and get the sides to fold in. So that may be a little hard to picture, but I will just do it here, and then I will show you what it looks like so that you can attempt to do this. And like I said, if at any point in time you don't understand, I think even on the stream you can stop the video and re-watch a section. So I will just push down, so it will come out to look a little bit like the Volcom, I believe it's Volcom symbol, to where there's this square in the background and then there's this bigger rhombus with an opening. So you can see these are open. So the tip and the bottom of the square we had stay at the bottom and the top, but the other corners become the middle of the middle. So the other corners of the square are right here. So they came in as the other ones went up, and now we have this shape. And what we're going to do to the other side is the exact same thing. And now that you have this one in the background, you can see the width that you need to make it. So attempt to make that width the same for the other side. So I will push the corner, and what I tend to do is I'll put the corner where the other corner is, where the other tip is, and then I know that I'm in the right spot. So then you just have to work the paper a little bit to get the shape to come out. And then just clean it up with your thumbnail. Okay, so now we have this big rhombus, and it looks a little complex, but it might start to look like you may be able to jump a little ahead from where we are if you are on top of it. But so what's going to happen is, now that we have these, you'll see that the sides open up. So we're going to go ahead and open up those sides and fold it. So now it kind of looks like a wolf, maybe. There's two ears, and then there's the main head, which is a kite shape. And yes, that is an actual geometric shape. It is not just the flying children's toy. I had some excess paper hanging out of one of the flaps here down at the bottom, so I just folded that in, and now you can't see it. So now the general shape is more perfect. So now that we have this, we're just going to take the bottom side, which is the kite shape, and fold it up to the top to match up with the tips of the other ones. So we have this flap that goes up, and the same on this side. So now we have a new isosceles triangle, right? But this one is not a right triangle, so it is not similar to the ones before. And so now that we have this triangle, you'll see once again it opens on the sides because that's what we did last time. But instead of opening it all the way, what I'm going to tell you is to just take one side, one of the little wedges on the inside of the paper, so here, and simply move it down, and you'll see that this part of the paper will spread out a little bit, but just go down until it flattens out again, and then push it in with your fingers. And you can do the same on the other side, so reach in, grab the middle wedge and pull it out, and just find a nice spot that the paper, that the corners meet up, and then push them in with your thumb and your other fingers, obviously. And then now, this is an important decision. You have to decide which of these you want to be the face and which of them you want to be the tail. And if you pick the wrong side, then it might offend the other one because you think it looks like a butt. I'm just going to pick this side. It does not really matter in terms of making the bird. It is relatively symmetric. So now you'll see the general shape of the crane, and then just these big triangles, but these will be the wings. So I'm just going to fold them down. You want to leave a little bit of slack on the sides, so don't necessarily fold it where it wants to. Fold it a little bit up. This just kind of makes it work a little bit better, and it looks a little neater, or nicer, or cleaner, whatever you want to use as your synonym. So now you have your paper crane. And what some of you might know and what some of you might not know is you can make your paper crane fly. So all you have to do is grab the breast region of your bird and the tail and pull the tail, and it will clap its wings together. If you push the wings up a little bit, then you will see that they can fly, so it can flap its wings. The frame rate on my video is not necessarily fast enough to show the flapping of the wings, but you can try that for yourself, and it should work for you. What I find is if you spread the ends down here at the bottom out a bit, then you can have the crane sit up. You might not be able to see that. So now it sits up on its own, and so yeah, there's your paper crane, and you can do that with any piece of paper that you find. So what I tend to do is when I get a receipt or a candy wrapper or something from a restaurant, I'll randomly make a paper crane and leave it on the table, just because I find it'd be fun to find something like that instead of just trash on the table when you're coming around to bus it. But with that being said, I will check the comment section to see if there's any questions, and there are not, because it is telling me there is no one watching, but that is completely my fault due to the fact that I had to start late. Like I said, the avocados were kind of getting to me, and I had to teach them a lesson. And I think they ended up teaching me a lesson in the end. My guacamole is rather brown and slightly pink, which is not necessarily the color you're going for when you make guacamole, but we will see how it turns out. So I want to thank you for watching the stream here, and I will be signing off. Thank you.